In this video, we will take a look at how a function call works from the perspective of the assembly instructions and from the perspective of the stack. So the example function that I'm going to use is this func, and it takes two arguments, arg1 and arg2. To begin, we'll take a look at what happens at the caller before calling this function. So to call this function, the caller has to pass argument 1 and argument 2. The caller does this by using the push instruction. So the push instruction basically loads the value of these arguments onto the stack. So the first value that gets pushed is arg2 followed by arg1. I'll explain in a bit as to why the arguments are passed in the reverse order. So once the arguments are pushed onto the stack, call is made to the function using the call instruction. So the call instruction implicitly pushes the value of the EIP onto the stack. This is done so that once the function call completes, the processor knows which instruction it needs to execute in order to continue the flow of the program. So this is basically the return address. And once the call is made, now the control is transferred to the function. Now let's look at the code that is inside of the function and see what it does. So once we are inside the function, the first instruction that executes is push EBP, which means the current value of the base pointer is pushed onto the stack. Old EBP. We don't know what this value is, but just for example, we'll say it is 200. So this value is now pushed onto the stack. And the next instruction sets a new value to EBP. So it moves the value of ESP onto EBP. So ESP is a pointer which gets dynamically updated as the stack grows. So currently ESP is pointing to 16, right? And we are moving the value of EBP to 16. So EBP had the value of 200. Now it has the value of 16. Once this is done, if the function uses any of the x86 registers, then those registers also need to be backed up. So I'm just giving this example of push EDX, assuming that the function is going to use EDX somewhere in its logic. So once the backup is done, it's now time to make space for the local variables that are defined inside the function. But before moving on to the local variables, I wanted to make one point. We are setting EBP to point to 16, and EBP kind of becomes the man in the middle now. What happens is any reference to the function's arguments or to any local variables is made with respect to EBP. Say for example, now there is a local variable in which I want to store the value of 10. So the instruction I give is store 10 in the address pointed by EBP minus 8. So EBP minus 8 is 16 minus 8, which is 8 again. So at the memory location 8, I want to store the value of 10. That's how local variables are initialized and accessed. Same goes for arguments as well. So if I want to access argument 1, I will add 8 to the EBP. So 16 plus 8. If I want to access argument 2, I do EBP plus 12. So which will take me to 28. And following this is the actual implementation of the function. So it does whatever it has to do. I didn't want to mention that and clutter the code. I just added one line here where the value of EAX is getting added to 99. So basically the function will execute and the value will be stored in EAX. After execution of the function, now we have to leave the function. For that, the program uses the leave instruction. So the leave is a composite instruction and it is made up of two sub instructions. So the first instruction moves the value of ESP back to EBP. So as I said earlier, ESP always points to the top of the stack. So currently ESP is pointing to 8. So when I leave the function, ESP will point to EBP. So ESP was, let's say, ESP was originally pointing here. Now ESP will point to EBP, which is 16. And now we are popping EBP from the stack. So when you pop EBP from the stack, it will no longer be pointing to 16, but it will be pointing to 200. Let's say it's somewhere down here, right? So ESP is pointing to 16, EBP is pointing to 200. And the last instruction that gets you out of the function is the return instruction. So the return instruction implicitly does a pop EIP, and you do a return. So the return is going to pop the value of EIP and give it back to the EIP register. So now the program is back at the caller, and let me also mention that ESP is now pointing to 24. So the caller takes the responsibility of cleaning up the final part of the stack which contains the function arguments. So it does this by adding 8 to ESP. So ESP is 24 now. If I add 8, ESP becomes 32. So this is the new value pointed by ESP. With that, we have cleaned up the stack. So one point worth mentioning here is cleaning up the stack does not mean that all the values in the stack are getting set to 0. It just means that ESP is getting pointed to where it originally was, which is 32. Here I have mentioned something called as cdecl. So cdecl is a calling convention in which the caller is expected to clean the last part of the stack. There is also another convention which is called std call. If the function had used the std call convention, then this cleanup would have happened as part of the function itself. Now we have just a return in this case, but if we had used the std call convention, we would be having return 8. So return 8 means that the instruction will pop the value of EIP, and it will also add 8 to ESP and set its position to the beginning of the stack the way it was before calling the function. Now to the final point on why the arguments to the function are pushed in the opposite order to the way they are defined. To understand this, let's look at a typical main function that's defined in C. So the main function takes two arguments, argc and argv. So argc is the count of arguments and argv is pointer to the set of arguments. So if we go by our normal intuition and push argc first onto the stack followed by argv, argc and argv. So this is like variable number of arguments. If the program wants to access how many arguments have been passed to it, then it will find it really difficult because it does not know the size of argv, right? Whereas if argv were pushed first and argc pushed later, it's easy. So the program always knows where to find the number of arguments. So it will be always at ABP plus 8. And once it has the count of the arguments, it can figure out the locations of the rest of the arguments. So with that, we have understood how a function call looks in assembly as well as how it translates onto the stack.